Alright, solutions for quiz 5 for Math 243. Midterm grades. They are right skewed with a mean of 75 and a standard deviation of 18. What it wants me to do is describe and justify the shape, center, and spread for the sampling distribution of the average of a class of 36 students. So what I'm saying is I'm not taking one student. One student I know that the mean is 75 and the standard deviation is 18. But that's not what I want. I want the average of 36 students. That number, I don't know that number because it depends on all the 36 students. But I can make predictions about it using the sampling distribution. So in order to use the sampling distribution, we got to talk about the shape, the center, and the spread. The shape of the sampling distribution turns out it's approximately normal. That might confuse you because it says right here it's right skewed, but it doesn't. It says right here that the parent distribution, the distribution of one student, is right skewed. But it turns out that when you average out 36 of them, the shape turns into approximately normal. The reason why is what's called the central limit theorem. And in our book, we say that the central limit theorem will make the shape approximately normal anytime n is greater than or equal to 30. In this specific problem, n equals 36. The center, because our distribution is approximately normal, this is the sampling distribution that's approximately normal, we want to use the mean. And the mean, okay, actually I'm going to use some notation here. Center, I want the mean. The notation I'm going to use for mean is mu sub x bar. Mu, because it's the population mean, but it's not the population mean of the parent distribution, it's the population mean of the sampling distribution. So you put this little x bar in the subscript. But it turns out that mu sub x bar is just the same as mu, which was given to me in the problem of 75. So mu sub x bar is the exact same as mu, which is 75. Spread, kind of the same idea. I want sigma, except now in the subscript I want x bar. Sigma sub x bar is not the same as sigma. It's not the same as 18. It's actually sigma over the square root of n. So it's 18 over the square root of 36, because that's our value of n. 18 over 6 is equal to 3. Shape, center, spread. Find the probability that the class average was above, actually I don't want this to be 90, I want to change this to 80. By sketching and labeling the relevant picture. Okay, I already got shape, center, spread, so what I'm going to do is draw my approximately normal distribution, which is hard to do on a computer. Middle should be at 75, and the spread is 3, so one standard deviation up is 78. 2 of them up would be 81, and 3 of them is 84. You can also subtract standard deviations and get these numbers. And what it's asking me to figure out is the probability that the class average is above 80. So here's 78, here's 80, 78 and 81. 80 somewhere in here. And so this probability right here, I can get this out of my calculator. And the way I will do it is by using the normal CDF function, which I'll show you how to use here in just a second. And my inputs will be my left bound, which is 80. My right bound, I don't have a right bound, so just put any big number here. 9999999, whatever. I'm going to use scientific notation to use the biggest number my calculator can understand. And then the mean, and then the standard deviation. Careful, it's this mean and this standard deviation we want to use, 75 and 3. If you put in 75 and 18, you're going to get the wrong answer. Okay, so the way we figure this out, or the way you get normal CDF, is under the distribution menu right here. So hit second and then variables to get into distribution. Normal CDF is the second thing listed. And if I tell it 80, the E for scientific notation is above this comma. So hit second comma. What did I say, 75 and 3. If I hit enter, it's going to give me this area here. 0.04779. 0.04, how about 0.0478 maybe if I round it off? or 4.78%. Find the probability that the class average was above 80. It's only 4.78% chance that the class average is above 80. Okay, in this one, I want to find, it's pretty similar to part B. I want to find the probability that the class average, but this time between 70 and 80. Two options. Option one is, well, yeah. No, I don't even want to do that. Okay, I'm going to do it. Option one would be to be kind of clever. Option one is saying 4.78 above 80. And kind of using symmetry, I can say 4.78 is below 70. Right, because 75 is my mean. So if this is how much is above 80 from part B, this is how much is below 70. And if I add those two up, I get 9.56. I think I added those right. 9.56 is not between 70 and 80. Right, 4.78 is above, 4.78 is below, so 9.56, the sum of these two, is not between these two values. So 100 minus 9.56, which is 90.44, is between. One way to get your answer would be doing something like this. But option two, kind of more what I had in mind, is to use this calculator function. So I guess either way you're going to draw the picture. So draw the picture down here, maybe in a different color. Jeez, it's hard to draw on a computer. So I have my distribution, which is supposed to look the same as this one up here. I got 75 in the middle, 78, 81, and 84. And then if I count down, I got 72, 69, and 66. And the answer I already figured out is 90.44, or at least very close, up to rounding errors. But option two, the way you could figure that out, or the way I envisioned you figuring that out, is you'd say, all right, between 70 is right here, and 80 is right here. So to find this area, I can either do this, or I can do this. I don't know why I care, but I'm going to shade this in a little bit better. Option two would be to use the normal CDF function in your calculator, just like we did up before, except now we want the area between 70 and 80, with the mean as 75. And the standard deviation is, what do we say it was, 3? So if I do that over here, I'm going to clear this out. I'm going to go into the distributions menu, so I hit second and then variables to get into distributions. The second thing is normal CDF, and I want to know the probability that we're between 70 and 80 if the mean is 75 and the standard deviation is 3. And what I end up getting is 90.44, same thing I got before. I guess I should make these all percentages. So two different ways you could answer that problem. Either way, you get the same picture, and you figure out that the probability is 90.44%. So that's the end of this quiz.